limit system. Interchangeability. Interchangeability normally is employed for mass production of identical items within a prescribed limit of sizes. If the variation in size are within certain limits, all parts of equivalent size will be equally fit for operating machines and mechanisms. Certain variations are recognized and allowed the size of the mating parts to give required fitting. So this facilitates select random from a large number of parts for an assembly and result in saving in the cost of production. In order to control the size of the finished part for interchangeable parts is called limit system. The important terms used in the limit system. Normal size. It is the size of the part specified in the drawing as a matter of convenience. Basic size. It is the size of the part to which all the limits of variation are applied to arrive at final dimensions of the mating parts. The normal or basic size of a part is both are normally same. Next is actual size. It is the actually measured dimension of the part. The difference between the basic size and the actual size should not exceed a certain limit, otherwise it will interfere with the interchangeability of the mating parts. Limits of sizes. There are two extreme permissible sizes for a dimension of a part. The largest possible size for the dimension of the part is called upper or high limit or maximum limit, and smallest size of the part is known as a lower or minimum limit. Then allowance. It is the difference between the basic dimension of the mating parts. The allowance may be positive allowance or negative allowance. When the shaft size is less than the hole size, then the allowance is positive. When the shaft size is greater than the hole size, then the allowance is negative. Then tolerance. Tolerance is the difference between the upper limit and lower limit of a dimension. It is the maximum permissible variation in the dimension. Tolerance may be unilateral or bilateral. When all the tolerance is allowed on one side of the nominal size, then it is called unilateral system of tolerance. It is mostly used in industries because it permits changing the tolerance value while still retaining the same allowance or the type of fit. When the tolerance is allowed on both sides of the nominal size, it is called bilateral system of tolerance. Next is the tolerance zone. It is the zone between the maximum and minimum limit size. The next is zero line. It is a straight line corresponding to the basic size. The deviations are measured from this line only. The positive and negative deviations are shown above and below the zero line. Upper deviation. It is the algebraic difference between maximum size and the basic size. Upper deviation of the whole represented by the symbol ES, and for of the shaft, and it is represented by ES. Lower deviation. It is the algebraic difference between the minimum size and basic size. The lower deviation of the whole is represented by symbol EI. Of a shaft, it is represented by EA, small a. Actual deviation. It is the algebraic difference between actual size and the corresponding basic size. Next is mean deviation. This is the arithmetic mean between the upper and lower deviations. The last one is fundamental deviation. It is one of the two deviations which is conventionally chosen to define the position of the tolerance zone in relation to the zero line. The degree fitness fits the degree of tightness or looseness between the two mating parts is known as the fit of the parts. The nature of it is characterized by presence and the size of clearance and interference. Clearance is the amount by which the actual size of the shaft is less than the actual size of the mating hole in the assembly. The clearance is the difference between size of the hole and the shaft before assembly. The difference must be positive. Interference is the assembly by which the actual size of the shaft is larger than the actual finished size of the mating hole in the assembly. Interference is the arithmetic difference between the size of the hole and the shaft before assembly. The difference must be negative. Different types of fits. First one is clearance fit. In this type of fit, the size limits for meeting parts are so selected that the clearance between them always occur. In the clearance fit, the tolerance zone of the hole is entirely above the tolerance zone of the shaft. In the clearance fit, the difference between the minimum size of the hole and the maximum size of the shaft is known as minimum clearance, and the difference between the maximum size of the hole and the minimum size of the shaft is called maximum clearance. The clearance fit may be a slide fit, easy sliding fit, running fit, slack running fit, or loose running fit. Next is interference fit. In this type of fit, the size limits for the mating parts are so selected that the interference between them always occur. In the interference fit, the tolerance zone of the hole is entirely below the tolerance zone of the shaft. In the interference fit, the difference between the maximum size of the hole and the minimum size of the shaft is known as minimum interference, and the difference between the minimum size of the hole and the maximum size of the shaft is called the maximum interference. The interference fit may be shrink fit, heavy drive fit, and light drive fit. Next is called the transition fit. In this type of fit, the size limits for the mating parts are so selected that either a clearance or interference may occur depending upon the actual size of the mating parts. In the transition fit, tolerance zones of the hole and shaft overlap. The transition fit may be force fit, tight fit, or push fit.